Okay, so in lesson 21, we're going to look at problems in mathematical terms. And really what we're focusing on in this lesson is independent variables versus dependent variables. So we're going to talk about what those mean as we work through a problem. So the first example says that Marcus reads for 30 minutes each night. Determine which variable is independent and which is dependent. Then create a table to show how many minutes he has read in the first 7 days. Finally, write an equation to represent the number of m minutes he can read given any number of days of d days. So first of all, we want to talk about what an independent variable is and a dependent variable is. So in our table, we know that we're going to be looking at minutes and days. It tells us right here, m for minutes, d for days. So an independent variable is one where it doesn't rely on any type of math being done to get it. You can just pick any number and then work from that number. The dependent variable does rely on the independent variable. So you have to do math to the independent variable to get the dependent variable. So in this case, he's reading for 30 minutes each night, and we're going to think of each night as a day. So that is our day there. So the number of minutes he reads for depends on how many days there are. So our days, or d, is our independent variable. I can choose any number of days. I can just pick a number of days and determine how many minutes he's read based on those number of days. The minutes, therefore, are going to be our dependent variable. The number of minutes he reads for really depends upon how many days he's read, because it tells us 30 minutes each day. It does want us in the table to do the first 7 days, so 1 day, 2 days, 3, 4, 5, 6, 7. So again, I can just pick any number of days and determine the number of minutes based on that number of days. I have to do math to the number of days, so do math to the independent variable to get our dependent variable. So if it says 30 minutes each day, that means 1 day would be 30 minutes. So I did 1 times 30 to get 30. So I'll do 2 times 30 to get 60, 3 times 30 to get 90, 4 times 30 to get 120, 5 times 30 to get 150, 6 times 30 to get 180, 7 times 30 to get 210. Now, one thing that I also use is if it tells me it's given any number of days here, if I'm given any number, that means I can randomly pick any number, which means when I'm given any number of something, that's typically going to be my independent variable, because that's a number I can just choose. It doesn't rely on any mathematical computations to get it. So in this case, our independent variable is the days, or d. The dependent variable is the minutes, or m. Okay, the equation from this table to get from our days over to our minutes, we have multiplied all of those by 30. So in other words, I'm taking d times 30, which remember we write as the number first, attached directly to the variable, and that gives me my minutes. Okay, there are other ways to write this equation if I was working backwards, but again, the minutes are still dependent upon the day. So we could write this as the number of minutes divided by 30 to get the days. Okay, so that is our first one. Typically in a table like this, in a ratio table, your independent variable is going to be in the left-hand column and your dependent variable will be in the right-hand column. So that's helpful if they're asking you to find the independent and dependent. Okay, so the next one says that Kira designs websites. She can create 3 different websites each week. Kira wants to create an equation that will give her the total number of websites she can design given the number of weeks she works. Determine the independent and dependent variables. Create a table to show the number of websites she can design over the first 5 weeks. Finally, write an equation to represent the number of websites she can design when given any number of weeks. So again, I'm seeing this given any number of weeks. So what that would mean is that that's going to be my independent variable, the number of weeks. I can pick any amount of weeks, and from that number of weeks is when I can do some math to it to get my dependent variable, which in this case would be number of websites. And I'm actually going to write total number of websites. I need to differentiate between the weeks and websites. For weeks, I'll use W, and then for total number of websites, I'll use T for total. So when I go to make my table, the number of weeks, or W, will go in my first column, and the total websites, or T, will go in my second column, independent on the left, dependent on the right. So again, since it says given any number of weeks, that means that that's that number that I can choose without doing any math to it. And from that, I can find my dependent variable. So they want for the first 5 weeks, so 1, 2, 3, 4, and 5. In the problem, it says 3 different websites each week. So 1 week would be 3 websites. To get from 1 to 3, I've multiplied by 3. So that means I'll continue that times 3 all the way down my table and work across. So 2 times 3 would mean 6. 3 times 3 would mean 9. 4 times 3 would mean 12. 5 times 3 would mean 15. So to get from my number of weeks to my total number of websites, I have done times 3, or websites times 3, or I'm sorry, weeks times 3, which I'll write as 3W is equal to the total. If I were to work backwards, I would be dividing by 3, so I'd be taking my total divided by 3 to get my weeks. Okay, so it's really just everything we've already done so far, just putting names on the independent and dependent variables. Okay, and then our last example, Priya streams movies through a company that charges her a $5 monthly fee plus $1.50 per movie. Determine the independent and dependent variables, write an equation to model the situation, and create a table to show the total cost per month given that she may stream between 4 and 10 movies in a month. So once again, in this case, her total cost is going to depend upon how many movies she watches. So totals typically depend on something in order to get them. So when we have a total, that is typically our dependent variable. Typically. We would be getting our total cost as our dependent variable, total cost, and I'll call that T for total. The independent variable here is the number of movies she rents, because it depends on how many movies she rents, what her total will be. So the number of movies. Now this one is a little different than what we've been doing so far because of this $5 monthly fee that's added on to every movie that you watch. So we'll see how that works when we write our equation and do our math to get our answer. So our independent is our number of movies, which we're calling M. And if they don't tell you the variable, you can just choose a variable that works with what you're given. For our dependent, I'm going to do our total cost. So I'll use T. You could use C for cost, whichever works best. So they want us to make the table given that she might stream between 4 and 10 movies. So that means I would want to start with 4 and work my way up to the 10 movies. Now, what's interesting with this problem is there's a $5 monthly fee plus the $1.50 per movie. So when figuring this out, what I would have to do is first multiply by $1.50. So 4 times $1.50 will tell me how much the cost of the movie is. But then I would want to add on that $5 monthly fee. So for each one, I'm going to be multiplying by $1.50 and then adding on 5 to it. So I'm going to take out my calculator to work through this. So if I had 4 movies, what that means is each one cost $1.50, so 4 movies times $1.50 would tell me the movies alone would cost $6. But I also have to include this monthly fee. So I also have to add on $5 to that. So that tells me the total cost for that month if she were to stream 4 movies would be $11. If she were to stream 5 movies instead of the 4 movies, I would have to find out how much the total for the movies would be and then add on that monthly fee. So now I'm doing 5 times $1.50 plus the $5 fee to get $12.50. Okay, for 6, it would be 6 times 150 to find out the number of movies plus the $5. So 6 times the 150 plus $5 gives me $14. I would do the same for each of the other ones, multiplying by 150 first and then adding on the $5. Okay, so I have taken time to fill in the rest of the table, just again multiplying by 150 each time and then adding the $5 on. So the table would continue on in this way. So in other words, what we're doing, if we're doing 4 times 150 or 5 times 150 or whatever, is we're taking that number of movies and multiplying it by 150. So for our equation, we would do 150 times the number of movies, or M, and then add on the 5 to it. We can write that as 5 plus 150M as well, and then that's going to give us the total cost. So either of those. Okay, so with what we call here a two-step equation, we have 2 operations, multiplication and addition. We're just required for that one operation, or that one order this year. We don't have to do the backwards one. So we're just going to stop there.